Hi, I'm here to discuss with you about VLANs and BTP. Let's get started. What is VLAN? A virtual LAN, or they call it VLAN, is any broadcast domain that is partitioned and isolated in a computer network at a data link layer called OSI layer 2. A LAN is the abbreviation for local area network, and in this context, virtual refers to a physical object recreated and altered by additional logic. VLANs work by applying tags to network packets and handling these tags in networking systems, creating the appearance of and functionality of network traffic that is physically on a single network but acts as if it is switched between separate networks. In this way, VLANs can keep network applications separate despite being connected to the same physical network and without requiring multiple sets of cabling and networking devices to be deployed. VLANs allow network administrators to group hosts together even if the hosts are not directly connected to the same network switch. Because VLAN membership can be configured through software, this can greatly simplify network design and deployment. Without VLANs, grouping hosts according to their resource needs necessitates the labor of relocating nodes or rewiring data links. VLANs allow networks and devices that must be kept separate to share the same physical cabling without interacting, improving simplicity, security, traffic management, and economy. Benefits of VLAN. When set up correctly, virtual LANs can improve the overall performance of a busy network. VLANs are intended to group together client devices that communicate with each other most frequently. The traffic between devices split across two or more physical networks ordinarily needs to be handled by the network's core routers. But with the VLAN, that traffic can be handled more efficiently by networking switches instead. VLANs also bring additional security benefits on larger networks by allowing greater control over which devices have local access to each other. Such an example is Wi-Fi guest networks, which are often implemented using wireless access point that supports VLAN. So there are two kinds of VLAN, static and dynamic. Network administrators often refer to static VLANs as port-based VLANs. A static VLAN requires an administrator to assign individual ports to a network switch to a virtual network. No matter what device plugs into that port, it becomes a member of the same pre-assigned virtual network. Dynamic VLAN configuration allows an administrator to define network membership according to characteristics of the device themselves rather than switch port location. For example of it is dynamic VLAN can be defined with a list of physical MAC addresses or network account names. What is BTP? So BTP, which stands for VLAN Trunking Protocol, is a Cisco proprietary protocol that propagates the definition of virtual local area network on the whole local area network. To do this, BTP carries VLAN information to all the switches in the BTP domain. BTP advertisements can be sent over 802.1q and ISL links. BTP is available on most of the Cisco Catalyst family products. Using BTP, each Catalyst family switch advertises the following in its trunk ports: management domain, configuration revision number, and known VLAN and their specific parameters. There are three versions of BTP, namely version 1, version 2, and version 3. The comparable IEEE standard in use by other manufacturers is GBRP, or the most recent MBRP. BTP provides the following benefits: VLAN configuration consistency across the layer 2 network, dynamic distribution of added VLANs across the network, and plug and play configuration when adding new VLANs. BTP provides the following drawbacks. When a new switch is added to the network, by default, it is configured with no BTP domain or password, but BTP server, but in BTP server mode. If no BTP has been configured, domain name has been configured, it assumes the one from the first BTP packet it receives. Since a new switch has a BTP configuration revision of 0, it would accept any revision number as newer and overwrites its VLAN information if the BTP password matches. However, if you were to accidentally connect a switch to the network with the correct BTP domain name and password, but with a higher BTP revision number than what the network currently has, such as a switch that has been removed from the network for maintenance and returned with its VLAN information deleted, then the entire BTP domain would adopt the VLAN configuration of the new switch, which is likely to cause loss of VLAN information to all switches in the BTP domain, leading to failures of the network. Since Cisco switches maintain BTP configuration information separately from normal configuration, and since this particular issue occurs so frequently, it has become known as collaboratively as the BTP bomb. So, like what I said, there are three BTP modes: BTP server, BTP client, and BTP transparent. So, um, on the BTP server, in order for us to remember it fully, it could do all of it. It could create, modify, and delete VLANs, synchronize itself, and forward advertisement. For BTP clients, the only thing that it cannot do is create, modify, and delete VLANs. It could synchronize itself and forward advertisement. For BTP transparent, it could create, modify VLANs only to itself. It cannot synchronize itself, but it could forward advertisement from other BTP servers or BTP clients. So the difference between version 1 and version 2 are almost the same, except for this following things: um, token ring support. So version 2 supports token ring bridge relay functions and token ring concentration relay functions. Unrecognized type length value support. A BTP server or a client propagates configuration changes to its other trunks, even for the TLVs. it is not able to parse. The unrecognized TLB is saved in NVRAM when the switch is in operating in BTP server mode, version dependent transparent mode. In BTP version 1, the BTP transparent switch inspects BTP messages for the domain name and version and forwards a message only if the version and the domain name match. Because BTP version 2 supports only one domain, it forwards BTP message in transparent mode without inspecting the version and domain name. Consistency check. In BTP version 2, VLAN consistency check, such as VLAN names and values, are performed only when you enter a new information through the CLI or CNMP. Consistency checks are not performed when new information is obtained from the BTP message or when information is read from MB If the MD5 digest of the received BTP message is correct, information is accepted. So for version 3, there, these are the new additions for version 3. So BTP primary server. Only the primary server is able to create, modify, and delete VLANs. This is a great change as you can no longer accidentally wipe all VLANs, unlike you could with BTP version 1 and version 2. Extended VLANs. Now you can synchronize VLANs in the extended VLAN range, which is 1006 to 4094. Private VLANs. If you have VLANs that are configured as private VLANs, then you can synchronize them with BTP version 3. RSPAN VLANs. Remote span VLANs can now be synchronized. MST support. One of the problems of MST is that you had to configure each switch manually. With version 3, MST configurations are synchronized. Authentication improvements. BTP version 3 has more secure methods of authentication. BTP mode off. If you did not want to use BTP for version 1 and version 2, then you had to use transparent mode. BTP version 3 can be disabled globally or per interface. Compatibility. BTP version 3 is compatible with version 2 but not with version 1. So you have to be careful with that. So the next step is our labs. So in our labs, we have 4 switches. And what I did is after we configure the VLANs and the trunking and the PTP, we're going to inspect the packets on each connection. So let's get started. So here, what we're going to do is let's configure first the VLANs. And Oh, the- yeah. Okay, then after that, we're gonna configure the BTP side of it. So BTP domain, let's say, uh, then you configure first the domain, and then you configure the mode and configure the version. So we're just gonna use version 2 for now. I'm gonna do a separate demo for version 3 later on. Okay. Then we'll go to the interfaces. So BTP interface. So it's very important that you don't you don't configure the encapsulation wrong on one of the ends of the trunk. So switchboard mode trunk. So we'll put this one for now and grab. So all the bottom ones we're gonna configure it as client. So we don't need to configure the VLANs because it's supposed to be configured by the server. So we'll start first with domain. So when did they configure it? So as you can see, since this one was null before, same as switch, it already grabbed that domain. So the next step is in the interface. So to verify it, um, we'll do show interface trunk to make sure that it's in trunking and it's on. Then if you do show VLANs, you have all the VLANs on it. And then if you do a show BTP status, you could say client and version 2. Just a second while I'll plug the rest of the connection. And so I plug in the rest of the connections for switch 2 and switch 3. So let's continue with the configuration. But before we will do the existing two switch configuration for switch 2 and switch 3, let's verify it first. So since these two are not pre-configured, so if we do show VLAN, it should not have any of those 10 to 50 VLANs. Then if we show BTP status, it should not have the domain name and it should default to 1. And then show trunk. But I believe the show trunk would show that it's trunking. Show interface trunk. Oh, maybe not. So let's continue with the configuration. Since this is version 1 and this is client, it should pick up the connection for it. Oh, wait, we didn't configure, forget to configure the other interface for switch 4, which is E02 and E03. So the interface range E0 dash 2 3. Then port, mode, no, trunk, encapsulation. U, and then port, mode, trunk. So from there, um, configuring interface slash just copy and paste. Then it should, once we exit on this, so if you do BTP status, it grabs version 2 short interface trunk should have to say on, then the trunking, and the encapsulation should be 802.1q. So show VLAN, grab all the VLANs on it. So going back to the tree, which will do the same. Um, oh, to, to, okay, so interface 03, then copy, then once we show VLAN, be able to grab all the VLAN 10, 20, 30, 40, 50, and then show the status. Oh, then to show interface trunk, which will let you see again the status of the trunking and what encapsulation. So that's it for now, and we'll continue on. Oh wait, you forgot to do the Warshark demo. So if you look at the Warshark BTP, it will show me the version. And I forgot the you're supposed to see the encapsulation. I have to do more research on this, guys. I'll get back on a follow up video because I'm still gonna do BTP pruning. I'm trying to find the VLAN information like the VLAN 10, 20, and 30, but I cannot find it right now. So on my next video, I'm gonna show to you in Wireshark where it is. Thanks, guys, and I hope you subscribe. Thank you.